Hey everybody, there was a discussion that was started on the forum and on Twitter, I think, by a user, Ben Senior, who wants to do more with Dragknife tools. And he proposed an alternate solution that I'll talk about. But first let me quickly recap what's going on with this. This is a Dragknife tool. This one's made by Donic Tools, and it's unpowered. It's just got a bearing in here, and then it's got a cutter, and the tip of the cutter is behind the center line of the tool. And this is meant to be put into the spindle of your CNC machine, and then, but you don't turn the spindle on. You just run it off, and as this moves along the tool path, that dragging action allows the blade to orient itself, so you could follow a curve, and the cutter will track where it's supposed to be. So the problem with these is that because it's unpowered, there's no way to know ahead of time what the orientation is, where the blade is actually pointed. And so if you wanted to cut on this line and you start out in the wrong orientation, pretty quickly the blade will track, but it won't track immediately, and so at the corner you can get some tearing action and a bad cut. And so and the same thing happens at the corners where you've got to change direction real rapidly. It can cut and tear. Also, because the point is behind the center line, the tool path that we follow actually has to go past the end of the segment so that the point ends up where it needs to be, where actually, if you can think, the center line is passed. And then the dress up that we have runs this until the point is at the end of the segment, and then it lifts it, but it leaves the tip still in the material. And then it performs a small rotary move, which allows that tip to pivot right on its point until we're oriented for the next cut. Then we plunge back down into the material and continue on. And we do this at every acute corner that needs that action. And that works okay, but first of all, it's a complex tool path. Then the bigger problem is that we don't know the starting orientation, so the user has to move over and manually position the tool. Now, the solution that Ben Senior proposed was to have a sacrificial area somewhere outside of the stock, or possibly inside, some safe area that we know that we can go to. And then before the cut, you move over and run a circle until the orientation of the blade is lined up for the segment that you want to cut. Then lift, wrap it, and plunge into position and do the cut. And then the same thing when you want to change direction, you could lift, go over, reposition, and plunge back in. The problem with that solution is that because this thing freewheels like this, and it should be really freewheeling easy with almost no, you can see that just under the force of gravity, this thing is freewheeling back in. When we move, we can get the position oriented correctly here, but if the machine rapids and stops, then we've lost the position again. The rapid and acceleration and deceleration is going to cause this thing to rotate to some unknown position again, and we just lost what we established. Another solution that comes up from time to time is to just back up from the starting position and then roll on and perform the cut that way, and then use the same kind of corner action. And that works, and it works very well as long as the cuts that we have are simple. For something like this, it would be fine. The user would have to manually select a start point, and then we'd roll on from there. But if the job that we were cutting had dozens or hundreds of parts all nested close together, what you'd want to be able to do is to automatically detect start points, and that becomes very difficult to identify what is a safe point for this profile that isn't gouging into the profile that's next to it. And the same thing is if there's interior cuts, where can you go that's a safe point that it isn't gouging some other part of the part. So that's the Dragknife tool, and I haven't done any more work on it because I kind of feel like as cool as these things are, they're very limited. Besides the problems with the corners, they're also, one material I'd love to be able to cut with this is leather. But if you put a fairly heavy leather down, the dragging action is just going to cause the leather to bunch up, unless you have something like a vacuum hold that can hold it down very, very tight while you're dragging laterally to make the cut. In the commercial world, they don't use a drag knife for cutting materials like that. They use an oscillating tangential knife, which serves as a cutting tool, but this is the rotation part is powered. There's a stepper motor or a servo motor that's handling the positioning, and then the cutter is oscillating up and down, almost like a sewing machine needle, very rapidly. And then with that, you don't need the heavy vacuum hold to hold the material down, and you don't have to worry about the corner action, because you can just lift and the stepper motor will reposition and you plunge, and it works almost everywhere for a lot of different applications. Unfortunately for us hobbyists, those oscillating tangential knives there just aren't very many of them on the market, and the ones that are quite expensive. And that's an application I think would be really interesting for the hobby world, and very doable. I don't see why somebody can't have a design that's mostly 3D printed, that could even take the rotary motion of the spindle and convert it into an oscillating action on the blade, and then a separate stepper motor for the positioning. A solution like that would be really interesting to the entire Shapeoko, these lower cost CNC routers. It would open up a whole range of additional materials that we can't cut right now. The other thing that I would like to see with it is the ability to alternate, even on a drag knife, to alternate automatically between a cutting tool and a creasing tool. I think there's a pretty big opportunity for a machine that can make a custom sized box for instance, an Etsy seller or something like that, where you calculate the size of the box that you want and then you cut it using a drag knife. But you also have to have the ability to crease the fold lines, and that means switching between the cutting blade and like a pizza wheel, a creaser. And these tools just don't do that right now. But that's why I would like to see a hobby class solution like an OTK that can flip over and run a creasing wheel as well. So I'd like to propose that somebody or several somebodies work on a solution for a oscillating tangential knife, because I frankly would love to work on the tool path that would for driving that. It's not terribly difficult, but it is adding an additional action or axis of motion. So you've got your X, Y, and your Z, but you're also controlling your, I guess it'd be the C axis of rotation for that knife. All right, so I don't want to discourage anybody from working on this idea. I think it has some merit, and it would be fun to at least experiment with. But I did want to point out what I see are the possible problems. And I also wanted to start the discussion around an oscillating tangential knife as maybe an open hardware project. If anybody would like to work on something like that, get in contact with me. And if you like what we're doing with FreeCAD Path, I would really encourage you to support me on Patreon or support the broader FreeCAD community on LiberaPay. And I'll leave links to both of those in the description down below. Thanks for watching. Bye.